Hello, this is Rui Almeida again, and making another video about skeletal structures and how we can use them to make animations. In this case, I will explain the initial pipeline to make web animations. Um, in my last video, I have explained how we can represent skeletal structures, and as an example, I have made a simple class in C#. In this video I'm gonna go a little deeper and I will explain what we can do using these skeletal structures. In particular to model humanoid-like animation and movement. Uh, for this I'm using BVH file format. Um, um, this file format was originally developed by a company called BioVision as a way to provide motion capture data. The name BVH stands for BioVision Hierarchical Data, and it gives some dynamism to skeletal structures, and it represents in a very accurate way biological moving skeletons like the ones from humans and animals. Okay, so let's see some BVH file. It has two main components. The first one it's called the hierarchy, and the second one is called the motion that we can find here. The, the hierarchy, it's where the structure is defined. We have the offset, that is a vector that defines the positions of the points, which we call the joints. We have every joint has also a channels component. This channel component defines the properties that are affected by the animation. Then if we scroll down a little bit, we can find the motion section that contains the dynamic information of the file that defines the movement. First, we have the frames, the frames of the number of frames of the animation. In this case, we have 561 frames. And then we have the frame time in seconds, which means that if we divide 1 by this number here, we will have the frames, the number of frames per second. So let's see how many frames we have here. So 1 divided by 0.01667. Oh, oops, something went wrong here. Let's make it again. So 1.01667. So we have 59, almost 60 frames per second. So in this case it goes far enough, as the human brain can perceive at most something like 25 frames per second. Okay, so then we have the motion lines. Each line has the values of all the channels from the hierarchy. In this case, for example, these first 6 values represent the 6 channels of the hips. Okay, represent these 6 channels, and the next 3 values represent Z and X and Y rotation from the left hip. So it is okay, this one and the next one and the next one. Okay. So what I have done is a parser for this file that translates the file information. In fact, I have made 3 parsers, one in C#, another one in JavaScript, and a third one in PHP. That is the one that I'm using here. Then I have made a player for the web. I've used HTML and JavaScript for the new generation of browsers that support the WebGL. Firefox, Chrome, and Opera support it. Internet Explorer does not support it, and I guess Safari supports it, but I'm not sure about it. So let's run this on the web browser, and let's see the result of the parsing of the hierarchy. Okay, so there we have the skeleton of this human figure. We have the joints and the bones of this humanoid skeleton. Now let me just uncomment some lines of code that define the motion, and let's see it in action. So okay, let me just uncomment this. Okay, oops, something is going wrong here. Okay, let's do it in smaller pieces. Okay. Okay, it is now ready. Let's run and see what's happening. So then we have this guy here making some movements, and as you can see, we have a perfect animation of this skeletal structure of this guy. Let me also show you something that I have done some years ago when I was doing my master's degree. I've used BVH files to make the movements of these humanoid creatures, and used a technique called match moving that some filmmakers also use. Okay. So I hope you have enjoyed, and I will soon publish some details of the player on my website.